So let's look at an example here. You have dilute aqueous solutions originally at 25 degrees. You mix them in a styrofoam cup. So we have this as our approximation for a calorimeter. Okay. The total volume of the reaction mixture is 100 ml. Temperature rose to 27 degrees Celsius. Estimate the heat of reaction. What's the formula for measuring heats of reaction? Q reaction equals negative C delta T, right? What's our delta T? That's the easy one. It went from 25 to 27, so our delta T is 2.0 Kelvin or 2.0 degrees Celsius. Okay. What's our heat capacity? What's the formula for heat capacity? It's C of the calorimeter plus C of the contents, right? We don't know what our calorimeter constant is, so, and that's why this one says estimate. So let's just say it's 0. We're just estimating. That's usually a small number. Okay. So if you're not given the information, just neglect it. What's the heat capacity of the contents? It's just pretty much just the water, right? And what's our water here? 100 mils of water is how many grams? What's the density of water? 1 gram per mil. Okay. And what's the specific heat of water? 4.18 joules per gram Kelvin. So that's your heat capacity of your contents. That would be 100 times 1 times 4.18. That gives you 418 joules per Kelvin. Okay, so heat capacity of our calorimeter and contents is at least 418 joules per Kelvin. Okay, we're estimating. It's just the water. So what's our heat of reaction? What's 418 times 2? 836 joules. Kelvin cancels out, so that's negative. Or since we're doing sig figs here, it would be negative 840 joules. 2 sig figs. Okay. Now, what's the significance of this negative number here? Negative sign. What happened when the temperature? What happened when you mix the two reactants? What happened to the temperature? It went up from 25 to 27. So in order to restore your reaction mixture to its original temperature, what has to happen? Heat has to come out, right? So we say that that reaction is generating heat. In fact, if you just leave it alone, heat's going to come out because it's not going to be suddenly hotter than the surroundings, right? So you would expect heat to flow out of your reaction mixture. So we say that if Q is negative, for Q of the reaction to be negative, you have the temperature for mixing should lead to the reaction should lead to a higher temperature for your reaction mixture. So we say that this reaction is exothermic. Okay?